Go ahead with Yoshi.
Hi, Professor.
Hi, welcome. Let's see. You should be able to share your screen with us, please.
Okay. Can you see my screen?
Yes, we can. Yes.
So I sent you an email about this, but I ended up losing a lot of my code. And so the last couple of days I've been trying to recode everything. But like Daniel, I was having that issue where running the code took forever. So what I'm showing you right now is sort of incomplete, but I will be sure to submit a
Okay, fair enough.
later on.
No worries. Again, to see how much you have done at this point, how much you have understood.
Yep.
Yeah.
So reading in the data and then trying to convert to numeric whenever possible, from an object to a numeric. So some of the column data types do end up changing to a float or an int, just to make things easier. So here I am converting the service end date to a datetime object. And I realize this now, but I've been using kilowatts as my y-axis
Okay, makes
column
sense.
instead of kilowatt hours. And so my predictions do look a little different to other people's. So to get the averages by year, month, and day, what I do is I group by year, month, and date. And I apply the mean of those groups to each of those specified groups. And so we end up with a data frame that looks like this, where you have, the dates and then the average for that date by year, by month, and by day. And so doing a little more formatting, so changing the column names to DS and Y, dropping any NAs, and resetting the index.
Good.
And so for each of DF by year, DF by month, and DF by day, the data frames end up looking something like this. So in order to fit the model, so this is just out of the box without any kind of tuning. I wrote a little function, so it instantiates a profit object. It fits in the data frame. It predicts, and we note that period is in units of days.
Nice.
Getting the two figures, and for some people, I noticed that their figures popped up twice. I figured out that the way to stop doing that is adding a little semicolon at the end.
Okay, good to know.
Just a little trick.
Good point.
So making sure that I did this for each of the three data frames, making sure that there are no nulls, because as it turns out, that creates a lot of errors down the lane.
Good.
So for year, this is what I did. I passed in the data frame by year and period of 365 days into my function. And then I got this table and then this plot over here. So we see that there is a sort of downward slope all the way until about 2019, 2020, and then there's a slightly upward trend, which is interesting. And so there's a couple.
Maybe the pandemic pushed us to not to utilize a lot of.
Yeah, that's exactly what I was thinking.
Maybe.
Yeah.
Good remarks. Okay, cool.
Yeah.
Okay, guys, this is real data. This is real production data.
Yeah, and that's what I found really interesting.
It's accurate, or we understood it accurately, but this is real production data. Okay.
Exactly. And I was thinking about why the trend would go downwards for everything after like 2012. And I was thinking maybe as New York adapts like smart technologies or solar panel technologies, maybe that's causing.
Very possible, of
course. So
yeah.
I'm not really sure, but that was just a hypothesis.
Okay.
So I did the same for predicting 10 years into the future. Get something that looks like this. Predicting 20 years into the future. This has a similar shape as the last one. I wish there was a way to fix the y-axis limits to get a better, insight into the trend.
Again, for the yearly data, there is not much you can do there. There is not much information to contemplate.
And then I repeated the same process for month. So this is looking 1 month into the future. It's very periodic. looking 6 months into the future, and 9 months into the future. And I wasn't able to run these two because again, it just takes so long to run the graphs.
Mm, mm.
So now we repeat the same process again, but for days. So this is looking 100 days into the future. I noticed that there are a lot of outliers here. I'm not sure whether that's because I'm looking into the kilowatts as compared to the kilowatt hours, but yeah, I'm not really sure.
Yeah, I'm not sure if it's properly the daily figures been calculated.
Yeah, I think I might need to look into that.
Yeah, everyone for some reason. Yeah, okay, fair enough. Good try
And
here.
so the idea was that I would do the same for 200 days and 1 year into the future, but I didn't have time to run that code.
Okay.
So looking into model tuning, so I wrote this other function to take in the type of growth option. So there's 3: linear, which we've just done above, logistic, and flat. So I run this function for a logistic growth option, and I use a cap of 60 because I was looking in terms of kilowatts, not kilowatt hours.
Okay.
But I probably, like you said earlier, I probably should have used a higher value.
Most likely.
Yeah. Yeah, again, I'm not too sure about the accuracy of these. So for the flat option, I used a higher cap of 200. And this seems to maybe generate slightly better predictions.
Okay.
Or like a better fit.
Okay.
But I think I'm going to
like.
examine that data better.
Okay, cool.
So again, I wrote a function for the seasonality. It's a very flexible function. You can modify the daily, weekly, yearly seasonality, and then add in the period, the Fourier order,
Nice.
change the change points, all of that.
Nice.
I planned to run this function for each of the 3 subsets that I had, but I didn't have time to do this because running it took so long. But this is what I've got for a period of 100 days and looking at a monthly seasonality. I think I probably do need to look at that fit again. And then
you
I
have
try
an assignment somewhere to show us the comparison of one model versus the other and the metrics that you calculated?
Yeah, so I wasn't able to do the comparison yet. It's still yet to come.
Okay.
But I tried again. I wanted to do the change points for each of those 3 data frames, but this is all that time allowed for. Okay. So in terms of model evaluation, I ran cross validation. It took an hour and a half.
No surprise.
Yeah. Yeah.
How many predictions did it calculate for you?
I think it did 11-fold cross validation.
Okay.
Yeah.
Cool.
By default, I didn't know how to change the option. Otherwise, I probably would have done 5-fold.
Good effort here, you see.
So we get this like performance metrics data frame, and looking at the MAPI, we see that for predictions that are closer to the end date, they are a lot more better. Yeah, they can be trusted a lot more. Yeah, exactly. Compared to if you're looking further out into the future, it gets more and more uncertain.
Exactly.
So this is all I've got for now, and I planned to do the 5 boroughs as well. Okay, great. Very good work, Ayushi. Thank you. Thank you. Thank you very much. Let's go ahead.